Okay, so we're in chapter 9 on systems of equations and inequalities. And this is the last section for this chapter. It's 9.4, and we're doing partial fractions. So before we do partial fractions, what we're going to do is we're going to kind of step back and think about how to add two fractions together, because adding fractions is the composition of fractions, and this section is really about the decomposition of fractions. So how would we add this together? Well, first we would find the LCD. And so the LCD is what? Well, we have this in the bottom here, and we have this in the bottom here. So the LCD is x minus 3 times x plus 2. That would be our LCD. Now, how do we get the first fraction to have that LCD? Well, I have to write the right numbers here. That's a 2. I'm going to multiply by x plus 2 over x plus 2 on the first one. And on the second one, I'm going to multiply by x minus 3 over x minus 3. So when I multiply those two together, that's going to be my LCD. When I multiply those two together, that's the LCD. And then when I get done, I can just add across on the numerator. So the first fraction is going to be 2 times x plus 2 over x plus 2 x minus 3 plus, then I'll have a negative 1 times x minus 3 over x plus 2 x minus 3. Now I'm going to distribute so I don't forget that, and then so I'll have a 2x plus 4. And since they have the same thing, I can just continue across in a whole numerator. And I'm just going to say, okay, well, this is all over x plus 2, x minus 3. So then I have a minus x, and then I have plus 3. Okay. Now, simplifying more, 2x minus x is going to give me x. 4 plus 3 is going to be 7. And I still have x plus 2, x minus 3 in the denominator. Now, since we can't reduce that, then that would be the composition or the addition, basically, of those two fractions. So what we're going to do, partial fraction decomposition, is the opposite of what we just did with adding the two fractions. So we're going to start where we ended, and we're going to work our way backwards to get where we had the starting question. And so with partial fraction decomposition, and it's going to be a p of x over q of x, where q of x, and here's the key thing. We have different things. This one's non-repeated factors. So with non-repeated factors, we're going to do this routine. Then we're going to have some with repeated factors. We're going to have some with other things. And so that's the key, is to always determine what is your q of x factored as. So first I'm going to factor q of x if necessary. The reason why it says it is necessary, because sometimes they'll already factor it for you, and they'll give you, two factors, and you don't have to do that part. And then we're going to use a variable, a, b, c, so on, as needed for the number of factors. So if we have two factors, we'll have a and b. If we had 3, we'd use a, b, and c. And if we had 26, we'd use a through z, kind of like what's shown here. And what we're going to do is we're going to set p of x over q of x equal to, and we're going to take a over basically our first factor, plus b over our second factor, plus c over our third factor, and so on until we have like there's a z over the 26th factor. And then we're going to multiply both sides of the equation by the LCD. And your LCD basically is the factored form of q of x. And so you'd multiply that whole thing times that, and that's going to eliminate all the fractions. So then we'll just have only the numerator part left. And then we're going to expand the right side and add like terms, and basically the left side too if we have something for p of x. And then we're going to set the coefficient of the like terms from the left side. So if we had like a 2x here, and over here we ended up with like a 3ax plus, something blah, blah, blah. Well, here the coefficient is 3a. Here the coefficient is 2. But the x is the key. So we have to have the same term, and then we just set the two coefficients equal. Okay. And once we do that, we're going to basically create a system of equations that we have to solve. And so all the solving systems of equations we've done, it's going to come into play here. So we'll end up with, most of the time, 2 equations, 2 unknowns, sometimes 3 equations, 3 unknowns, and we'll work our way through and we'll solve them to get to what A is, what B is, what C is, or however many there are. And then we can put the A over the first factor, B over the second factor, C over the third factor, and so on. So that's what we're going to do. So let's start easy. And basically, all of the things we're doing in here is perform partial fraction decomposition. All right, so what do we have here? First off, what we have to look for is this is factored, so we're good there. Now we're going to set this equal to, and we're going to set the two terms. We have x minus 3 and the x minus 2, and we're going to use a and b because we have two terms. So we'll have a over the first term, x minus 3, and then we'll have plus our b over the second term, the x minus 2. So that is our first step. Now the next step is multiply the whole thing by the LCD, which is just x minus 3, x minus 2. Okay, so when we multiply this times this, guess what? You just get the numerator. When you multiply this times this, the x minus 3's cancel, so you have a times x minus 2. And here, the x minus 2's cancel, so we'll have b times x minus 3. Now we have to simplify, so that gives us x equals ax minus 2a, and then plus bx minus 3b. Now we've got like terms. We have basically our x terms, and we have what we call our number terms, basically, because we don't know what those numbers a and b are. And so what we do is we say, okay, well, let's rewrite this as x equals a plus b times x. So we're factoring that x out of those two. And then what we're going to say is, then we just have minus 2a minus 3b. Okay. Now the next thing said to do is set the terms equal to each side. So here, the x term has a 1. It's just an understood 1. So we're going to set 1 equal to that. So we'll have 1 equals a plus b. And then we have the number part, and that's equal to the number part over here. Well, guess what? There's no number part over here, so that's 0. So then 0 equals minus 2a minus 3b. And now we have our system of equations, okay? So we have, 1 equals a plus b, and 0 equals minus 2a minus 3b. So now what we want to do is we want to eliminate one variable, or substitute one variable in for the other one, or however we want to do it. I think I'm going to go back to elimination, and I'm going to multiply by 2, because if I do that, I'll have 2a, that's minus 2a, and they cancel pretty easy. So if I multiply here, that goes down here, and that gives me 2 equals 2a plus 2b. And then I can just add directly here. So that gives me 2 equals, those cancel, minus 3 plus 2 is going to be a minus b. Or if I take and multiply the whole thing by minus 1, b is equal to a negative 2. So that is what my b is equal to. Now I can solve for a. I could plug it into either of the original equations. If I plug it into the first one, I have 1 equals a, and then b is minus 2. So then I add 2 to both sides. So a is equal to 3. Okay. And now my partial fraction decomposition turns out to be, all I have is the original x over x minus 3 times x minus 2. Well, that's just going to be equal to the 3, which is a, over x minus 3 plus b, which was the negative 2 over x minus 2. And that then is my partial fraction decomposition. Now here I have two fractions, and I could add them both together and get back to here, but what we're doing is we're going the other way. We're going from something already been added together to something that we have partial fractions that we could add together eventually if we needed to. All right, so that's the end of part 1, and we'll be back to do more of these.